On to the second part of the question. When one end of the rod is at point A on the y-axis, the midpoint is at P, and okay, let's draw this. So we've got a curve, x, y. Y equals a quarter x squared. Point P. One end of the rod is on the y-axis, so something like that. And this is point A down here, and this is the origin here. Let R be the region bounded by the following. So it's basically going to be this bit, isn't it? That's going to be the R there. Let's just check. It's bounded by the curve, the y-axis, and the half rod AP. Got it. Show that the area of... So basically find the area of R. Okay. So how we're going to do this is we're going to find the equation of the line at between AP. So let's figure out the equation of this line. What do we know about this line? Oh, theta equals alpha. Okay, so let's fix theta to be alpha, and then we won't move that. So what does that represent? It's that, and also it could be that one as well. Because remember, theta was the angle of the line, right? So we know that at the point A, the x value is 0. So x was 2 tan theta minus b cos theta. And at A, x equals 0. So we have 2 tan theta. 0 equals 2 tan theta minus b cos theta. Now we've got two choices. We can isolate. So we can isolate theta, because we've got two unknowns in this equation, right? We've got theta and b. So we can either isolate theta or a function of theta, so like sine theta or cos theta, or we can isolate b and explain b in terms of theta or sine theta, cos theta in terms of b. So we've already decided that we're going to fix alpha, right, here. We fix theta to be alpha, so we're not going to move alpha. So let's write b in terms of alpha. Does that make sense? B must equal 2 tan theta over cos theta. And of course, when I said theta, I meant alpha, because it's given us alpha. Okay? So B must be equal to this thing. Right, what do we need next? We need the y value. So y was equal to, I think it was tan squared alpha in this case, because we know what theta is, minus b sine alpha. So b, we now know, is this thing. So we have tan squared alpha minus 2 tan alpha over cos alpha sine alpha. So that looks to me like y is equal to minus tan squared alpha. Right. Now let's construct this line. So line AP is equal to, well, line AP, I should say, has equation. Y equals gradient, which is tan theta, tan alpha, sorry, x plus the constant, which is minus tan squared alpha. So minus tan squared alpha. Okay, so that's the equation of a line AP in terms of alpha. Well, yeah. Right. So now we need to work out the area. So if we do the integral between some limits, we'll do the limits in a second, of the curve x squared over 4 minus the line. Right? That gives us the area in this, the area of R. Right? Because if we minus the line, when it's negative, it will become positive again down here. I hope that makes sense. Okay, sorry about that. I was, I don't know, I was just disturbed by, my tea was ready, so I've had to stop and come back again. So I think the last thing I was doing was explaining why this area here is equal to this integral, right? I mean, I don't think it's in the A-level syllabus. I think in the A-level syllabus you're always advised to, if you've got something like this, work out this area and then work out this area. So I suppose this might be a thing to learn, which is that, yeah, if you have a function like this, and one of them goes through the x-axis, and you want to know the difference between them, you can always do the upper one, take away the lower one, even if it goes through the x-axis, and so it becomes negative. Hopefully that makes sense. I mean, if you think about each strip, if you think about it as a series of strips like this that you're adding together, if you do this one, which is getting close to 0, minus this one, which is negative, the minus becomes positive, so you're adding lots of positive strips together, right? Which is why the area becomes positive. Hopefully that makes sense. Okay, but either way, it's something that's worth knowing. So now what we need to do is, let's find out the limits. Well, lower limit's going to be 0, it's obvious. Upper limit is when what occurs? Well, if we remember, this here was b. So if we sort of turn this into a triangle, we get x is equal to b cos alpha. And we decided what b was before. B was... there it is. 2 tan alpha over cos alpha. 2 tan alpha over cos alpha times cos alpha. So obviously these cancel. 2 tan alpha. Okie doke. So that's in the top. 2 tan alpha. So now if we set this equal to square bracket, x cubed over 12 minus x squared over 2 tan alpha plus, because it's minus and minus, x tan squared alpha between 2 tan alpha and 0. So this is 8 tan cubed alpha over 12 minus 2 tan cubed alpha plus 2 tan cubed alpha. So those two obviously cancel and leave us with divide them bottom by 4, so 2 over 3 tan cubed alpha. Hopefully that is the correct answer. Yes, it is. Okay, so let's just remind ourselves what we did with this one. We fixed theta to be alpha, and then we asked ourselves, what did we ask ourselves? We asked ourselves what the x, we knew the x coordinate of A was going to be 0. So we rearranged this to tell us what B has to be in terms of alpha, right? once we know that, we can put it into the y equation to find out what y is in terms of alpha. And the reason that we want to get b in terms of alpha is because, well, I mean, partly it's because the answer doesn't have a b in, so we know that we've got to get rid of b. But partly it's because it's well, no, that is the answer. Yeah, that is the answer. So the answer doesn't have a b in. If the answer had a b in, we might put alpha in terms of b. But in this case, we put b in terms of alpha to get rid of b. Then we find out the equation for the line AP. And how did we do that? We knew that this was the gradient. Oh yeah, and then we got the y-intercept, which is minus tan alpha squared. Sorry, tan squared alpha. And then we put that into this integral here, which gives us the area that we're after. Remembering, of course, that we can do this. We don't have to worry about when it crosses here, for example. This is okay thing to do to give us the area trapped between those two lines. And then we just solve it for x. We end up with 2 over 3 tan cubed alpha. So hopefully all that makes sense. Well done if you got there yourself.